Okay, here's our help video for pH, pOH, H plus concentration, and OH minus concentration. Keep in mind that if at any time you feel like you don't realize how I was able to figure out some equation, I will have an equation box down here for each one of our problems. And that equation box is directly from our packet, basically. And that packet is the one where we figured out that pH plus pOH equals 14, or when we figured out that H plus times OH minus equals 10 to the negative 14th. So I will have all those equations down here for us. So just make sure you know that that's where I'm getting that information from. You have that information in your packet. Also make sure that no matter how fast I go through these problems, remember on this video you're always able to pause and rewind. And I'm going to take you through the same problems that are on your pH worksheet that was due in class. So if that was a tough one for you, I would say get that out, have it out in front of you, and watch as I work through them. And if I'm going really fast, you can slow me down, you can pause, you can do whatever you need to, okay? So let's go. All right, here's our first problem. Calculate the pH of a 0.001 molar solution of hydrochloric acid. I like the first step of every one of these problems to be writing the dissociation equation. So I know that if I put hydrochloric acid in water, it will produce H plus ions, and those will dissociate from Cl minus ions. Okay, this is the cation, this is the anion, this was the cation, this was the anion. All right, so if I know that the pH, if I know the concentration of hydrochloric acid is 0.001, I can also see that there is a 1:1 molar ratio here. I can put ones in front of all of these. So because there's a 1:1 molar ratio here, I know that if the concentration of the acid is 0.001, the concentration of H plus is 0.001. In other words, I just figured out that the concentration of H plus is equal to 0.001. The problem is asking for pH. What's the relationship between pH and H plus? Well, I know that pH equals the negative log of the concentration of H plus. At this point, I don't know if you're able to do logs in my head. I wouldn't bother doing that. Get your calculator out. Negative log of 0.001 equals 3. And that is our answer. The next problem, calculate the pH of a solution containing 0.34 moles of nitric acid and 735 liters of solution. Again, first step, let's write the dissociation equation. Whoops. There we go. All right, there is nitric acid. That will dissociate into H plus ions and nitrate ions. I can see that it's already balanced, so I have a 1:1 molar ratio here. And now I want to figure out the concentration of the acid. In order to do that, I know that molarity equals moles per liter. I'm given moles. I'm given liters. The molarity is equal to 4.63 times 10 to the negative fourth. Now that I have the concentration of the acid, I can also figure out the concentration of H plus. Because it's a 1:1 molar ratio, I know that the concentration of H plus is equal to 4.63 times 10 to the negative fourth. Okay, now that I know the H plus concentration, now it's easy for me to get pH, because I know that pH is equal to the negative log of the H plus concentration, which is negative log of 4.63 times 10 to the negative fourth. Plug that into my calculator, and I will get 3.33. And that is the pH of that solution. For this problem, I know how many grams of nitric acid I have, and I know how many liters of nitric acid I have. First step, nitric acid dissociates into H plus ions and nitrate ions. All right, let's figure out the molarity of the nitric acid. 4.5 grams of nitric acid, I need to convert this into moles of nitric acid. I know the molar mass of nitric acid, using my periodic table, is 63.02 grams, and that is the mass of 1 mole. Grams will cancel, so now I know that I have 0.0714 moles of nitric acid. I'm going to dissolve that in 2.3 liters of water, meaning that my molarity is 0.031. Okay, so I just figured out that this acid has this molarity, and I can see that there is a 1 to 1 to 1 molar relationship, or molar ratio, so the concentration of H plus is also 0.031. In other words, I just figured out the concentration of H plus is 0.031 molar, and I want pH, and I know that pH equals the negative log of the concentration of H plus. That comes out to be the negative log of 0.031. If I put that in my calculator, I will get 1.5 as the pH of this nitric acid solution. Next one. I want to calculate H plus and OH minus concentrations for lithium hydroxide if I know the molarity is 0.013. Let's write the dissociation equation. Lithium hydroxide will dissociate into lithium ions and hydroxide ions. I know the molarity of the lithium hydroxide is 0.013. Because there is a 1 to 1 to 1 molar ratio, I know the concentration of OH minus is also 0.013. In other words, I just figured out that the OH minus concentration is equal to 0.013. There's my first answer, but I also want H plus. I just figured out OH minus. So I know that OH minus times H plus, oops, get rid of that, equals 1 times 10 to the negative 14th. So if I just sub in what I know here, I know that 0.013 is my OH minus concentration here. So what I want to do is set up a simple algebra equation. If I want to solve for H plus, I'm just going to divide 10 to the negative 14th by OH minus. So I know that my H plus concentration is equal to 10 to the negative 14th divided by my OH minus concentration, which is 0.013. If I use my calculator for that one, I know that my answer comes out to be 7.7 times 10 to the negative 13th. And that is my H plus concentration. And that is my other answer. This one is no different. I want to write my dissociation equation first. Nitric acid, when put in water, will split into H plus ions and nitrate ions. The problem tells me that the molarity of the acid is 0.15. Because there's a 1 to 1 to 1 molar ratio, I know that the H plus concentration is also 0.15. In other words, I just figured out that the H plus concentration is 0.15. There's my first answer. But I also know that the concentration of H plus times the concentration of OH minus is going to get me 1 times 10 to the negative 14th. So if I want to solve for OH minus, I'm just going to do 10 to the negative 14th divided by H plus, which is 0.15. Do that on my calculator. The answer comes out to be 6.67 times 10 to the negative 13th. And that is my OH minus concentration. Next one. First step here is no different. I want to write my dissociation equation. So calcium hydroxide will dissociate into calcium ions, which are +2, and hydroxide ions, which are -1. Now look at the equation over there on the left, okay? If I'm going to balance this, I know I need 1 calcium and 2 hydroxides for every 1 calcium hydroxide. So I have a 1 to 2 ratio this time. All right, let's proceed as we did before. I know the molarity of my acid, or the concentration of my of my base. The concentration of my base is 0.0200 molar. In this case, we've got a 1 to 2 molar ratio. That means the concentration of OH minus will be twice that of the acid. So OH minus concentration this time is 0.0400. In other words, the concentration of OH minus is 0.0400. Here's my first answer. And I know that H plus times OH minus is going to get me 10 to the negative 14th. If I want to solve for H plus, therefore, H plus equals 10 to the negative 14th divided by my OH minus concentration. So H plus concentration equals 2.5 times 10 to the negative 13th. And there's my other answer. All right, this is one of the more difficult problems on there. It's asking for the pH of the aqueous solution of NaOH when the, it's asking for the molarity when we know that the pH is 12.9. Okay, so the pH is 12.9. What is the molarity of that basic solution of NaOH? Let's write our dissociation equation. NaOH, when put in water, will dissociate into sodium ions and hydroxide ions. There is a 1 to 1 to 1 molar ratio there. All right, what information are we given? We know that pH equals 12.9. We want molarity of the base. Let's try to figure out what we can get from pH. If we are given pH, we can figure out pOH. I know that pH plus pOH equals 14, so 1.1 is the pOH. If I know pOH, I can figure out OH minus, because I know that OH minus is equal to 10 to the negative pOH, which is 10 to the negative 1.1, which is 0.079. That's the concentration of OH minus. I just figured out the concentration of OH minus is 0.79. Well, there is a 1 to 1 molar ratio here. So if the concentration of OH minus is 0.079, the concentration of sodium hydroxide must also be 0.079. What's this problem asking for? It's probably asking for molarity of the sodium hydroxide. Molarity is concentration. So molarity of sodium hydroxide is 0.079. There's your answer. We're going to stop there, and the second part of the screencast will be on the link directly following this on my website. I just don't want to exceed a certain amount of time per video because I kind of have like a 15-minute max on these. So please click the next video, and I will see you there.